Yeah, after downloading and preparing the dataset in the previous section, we are now ready to create the PyTorch data loaders we will be using for fine-tuning the model later. So for that, I want to show you first the figure before we implement the code, because I wouldn't say it's super tricky, but there's one important aspect to consider here. And so the text messages, they have different lengths. So for example, here are 3 example text messages. They are not exactly from the data set. I chose shorter ones here because in the data set they would be too long to fit into this figure. But if we have this message, this is the first text message, and then here this is another text message, and then this is the third text message, which is very long. You can see they have all different lengths if we convert them into token IDs. So each has a different number of token IDs. And when we create mini batches or batches for training in the data loader, these are tensors, and tensors have to have the same number of elements in each row. For example, if we have 10 training examples, 10 rows in that batch, each of them has to have the same number of token IDs. So how do we accomplish that? How do we make the number of entries or token IDs the same for each training example? So what we can do is we can pad the sequences to the longest sequence in the batch. And what we are doing here is we are using a token ID that is usually not used for many other things. For example, here, the token ID 50,256, which is the end of text token, and we are appending it here. So first we have to figure out what is the longest sequence. So if we only had a data set consisting of 3 training examples, we would check the lengths here and see, oh, this is the longest training example. And so we will find out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tokens. And so we have to make sure that every entry has 11 tokens now. So here in this case, because we only have 5 tokens, it means that we have to add 6 padding tokens. So here we can see 1, 2, 3, 4, 5, 6. We are adding the 50,256 padding token 6 times. And here in this case, we are adding it 5 times. So we make each sequence 11 tokens long to match the longest sequence here. And there are, multiple ways we can do that. We can do this for each batch. So one batch might have the maximum token length of 11. One other batch might have the maximum token length of 13, another one 15. Or what we can do is we can check the longest training example in the data set and then pad all the examples to the longest training example in the data set. And that is what we are doing here in this chapter. In the next chapter, in chapter 7, instruction fine-tuning, I will show you how we do this on a batch basis. For simplicity now, we are finding the longest sequence in the whole data set and then pad all the other ones. Okay, so let's see how this looks like in code. So, and by the way, we will be using the tick token tokenizer again. And just to show you the 50,256, that's the end of text token. So how we are going to implement this is we are going to use the dataset class, again, the dataset class from PyTorch. And here just copy pasted it so it doesn't take forever when I type this. So I will walk through this more slowly. This is a bit different from the data set that we used for pre-training. So in pre-training, by the way, we didn't have that issue with different lengths because we determined the length, right? We set the context length and then we had these sliding windows and we made sure that each window has the same size. So in that case, we never had to worry about different lengths because we created these lengths. Now it's a bit different because we have this data set where each has a different length here. Okay, so what we're doing is in this dataset class, by the way, it's not complete yet. I will add a bit more code once I explain this part. So we have a CSV file that we want to open. This could be, for example, the training, validation, and test set here. And then the tokenizer, that would be our tick token tokenizer. Then we define a maximum length. In this case, this will be determined. So we can either say we want to have a specified length, let's say 10 token IDs, 100 token IDs, or whatever the model supports. or we can just say the longest sequence is based on what we have in the training set, like I showed you. But yeah, we can restrict this further. For example, if we want to truncate it more, if we, in this case, if we want to have just 5 or something like that. And why is that useful? If you think about an application where you work with long documents, for example, let's say you want to classify newspaper articles. You want to develop a classifier that categorizes them as sports article, politics, finance, and so forth. Maybe you don't need the whole article. Maybe some articles are so long, maybe 100,000 tokens or something, that it wouldn't be working with your LLM. So you can say, oh, I only want the first 1,000 tokens because it has already enough information to build a really good classifier. And then I don't need to feed my LLM 100,000 tokens. So you can artificially, truncate the length here. And then we define what token we want to use for the padding. So yeah, we read the data set here. And here what we are doing is we are tokenizing the texts. So this is the familiar encode method we used before. And we do this for each row in the data set. And if we don't use the maximum length that we specify here, then we find it ourselves based on the longest example. It's similar to what I've done here, where I looked at all these examples and found, oh, this is the longest one. And so based on that, we say, oh, the longest one is 11, so we have to pad everything to 11. So I will implement this method shortly. Otherwise, if we have a max length, then we truncate to the max length here. Yeah, and then we pad this every element or every training example according to the max length. So we have the encoded text, and then for what the difference is between the max length. So for example, if this is, let's see, if we have a length of 500 and our max length is 1000, then the difference here is 500. So 1000 minus 500. And we say 500 times pad token ID. So we add 500 padding tokens to the encoded text, which has length 500. So it will have length 1000 after this. And we do it for each example in the text. So we are essentially determining the maximum length. Also, we have it here. And then we add the number of tokens corresponding to the difference between the actual length and the max length, so that we fill up the length up to the max length. It's what you are seeing here essentially. Okay, so this is the init method. This happens all when we construct the data set. So then next we have a get item method. Let me add this here. So the get item method will retrieve one example. So here it's similar to what we have done before. There's an index, and by the way, this is just like a PyTorch convention of how the data loaders work, the data sets work, and then the data loaders operate on the data sets. So index is a number. So for that we need actually, 1 second, we need the length method. So the index is a number between 0 and the length of the data set. So if we have, in our case, let's say for the training set, 1045 examples. This is, the index is a number between 0 and 1045, and it will select a random entry from the data set, and it will also get the corresponding label. So this is the text, and this is 0 or 1, depending on whether the email is ham or not ham. And then we convert it into tensors. Yeah, and then the only thing I have not explained yet is how we get the longest length. So yeah, depending on how you want to implement this, I have a verbose version, and later in chapter 7 I use also a shorter version. So that's actually very simple. What we are doing is we are just brute force iterating through all the encoded texts, the tokenized texts. And we say, if a given text is longer than the max length, then we update the max length. And a shorter way to write this would be, just like that, depending on which one you prefer. If you are more familiar with Python, you might find list comprehensions, or here like just a generator more readable, or here in this case, the more verbose way of doing it, but it's essentially just finding the longest sequence brute force using traditional Python code. Yeah, so that is our data loader, or sorry, not our data loader, our data set. The data loader will come in a few moments. So let's first initialize our data set here. So what I'm doing is I'm initializing it with a training data set first, and then we don't set a max length, which means that the data set will determine the max length based on the longest encoded length, like we just discussed. So this will be my training data set. And then I can print out what is my max length, what is the longest sequence. So if I execute this, I will find it's 120. And it's been a long time. So I grew up in the 90s, and I remember SMS text messaging was very popular. Nowadays, everyone uses iMessages or WhatsApp, where you don't have any limit how many characters you write. I'm not sure, but I think if I remember correctly, the maximum number of characters was 120, which might explain why the longest sample in this training set is 120. In any case, so just as a side note, so we have now the longest training example of 120. So that is how we pad our training set. And then we do the same thing for the validation set and the test set. Now, there could be longer examples, not in this case, maybe because based on what I said, text messages were maybe limited to 120 characters. But if you're working in a more general case, there may be examples where you find that a record in the validation set or test set is longer than something that has been in the training set. So here, what we're doing is we are truncating it to the training set length. That is because, we'll get to that later, because we are going to fine tune a certain position, a certain token ID. I will explain other ways of doing it also later as, let's say, bonus material. But for the way we implement the LLM, it is important that the validation and test sets have the same lengths as the training set. So that's why I am restricting that here. So another way you could do it technically is you could also determine the length based on the whole data set before we split it up and then use that length. And by the way, I don't think though they are longer than 120. So I'm just doing it for best practice reasons, because in model evaluation, the best practice is also to use the same parameters derived from the training set on the validation set and test set, and not use all the data to determine settings, because that would indicate we are considering information that would not be available at test time. So we are kind of like almost cheating if we would look at the lengths of the validation and test set. But this is again a topic for model evaluation. If you're interested, I mentioned my other article. So here I'm just doing it also for best practice reasons. Let's see if I have a figure here to illustrate where we are. So what we have done now is we have these original text messages, and then we made them all 120 tokens long by adding these padding tokens, the 50,256. So this is our data set. And then we have also the class labels, zeros and ones. So that's what we have done so far. But the one step that is missing, I mentioned in the beginning of this section, we are going to create the data loaders. So far, we only created data sets. So let's also create our data loaders. And this is code, that is very similar to what you have used before in chapter 2 when we set up the data loaders. So here we set the number of workers. I mentioned there might be some issues on certain machines, and also in Jupyter notebooks. Usually I don't recommend using multiprocessing. So just setting it to 0, but you can increase this and see if it works on your computer. And then we set the batch size to 8, and everything else is the same. We are shuffling for the training set. We don't need to shuffle for validation and testing. And then also the drop last equals true, which I explained in a previous video, that it will drop the last batch if the number of examples in the training set is not divisible by the batch size. And yeah, and this is it. So let's execute that. And let's maybe also do the dry run. I mentioned before, I like to just iterate over the data set just to make sure there are no bugs. You can do that also for the validation and test set, and just to make sure the sizes of the input and targets are what we expect. And so we can see each batch has a size of 8. Or in this case, it will be the last one, but yeah, it should be fine. So we are just making sure the batch size is indeed 8 and the number of tokens is 120. So this looks okay. And the labels, of course, corresponding to the 8 examples also have size 8. So this looks all good. And then lastly, we can also just print out the length in terms of how many batches do we have in the training, validation, and test set. So we can see we have 130 training batches, 19 validation batches, and 38 test batches. And so with that, we have now the dataset prepared and loaded. The next step would be loading the model, the pre-trained model, before we can modify the model and before we can fine-tune the model on this dataset.
Get this book at Manning.com.